We're going to take a look at how to graph a square root function and then a square root function that has had some transformations on it. So the easiest way to graph square root functions is to compare it to the graph of y equals the square root of x. So we're going to start by graphing y equals the square root of x, and then we're going to use that to graph this function, which is the negative square root of x plus 2 plus 4. Now notice you can only take the square root of positive numbers. So I only want to put positive numbers in my x column here. I'm going to plug in positive numbers for x and then take their square root. In addition to that, I really only want to take square roots of numbers that are perfect squares, because if they're not perfect squares, then it's hard to take their square roots. So if you think about what numbers are perfect squares, 0 is 0 squared, 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and 16 is 4 squared. I'm probably not going to get up to 16 because my graph only goes to 10. So in my x column, I'm going to put these numbers because those are numbers that are easy to take the square root of. So 0, 1, 4, and 9. Now I'm not going to 16 because my graph doesn't go out that far. In my y column, I'll put the square roots of those numbers. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So again, I chose these numbers because it's easy to take the square root of them. These are perfect squares. Now I'm going to graph each of these points. So here's 0, 0, 1, 1, 4, 2, and 9, 3. And this gives me the graph of the square root function. Now, the square root function is different from polynomials or lines because it's only defined for positive numbers. And so our domain and range are different. If we look at our domain are x values. This is kind of our starting point. We can't have any x values over here. So we look at our starting point, which is the point 0, 0. And that tells us the smallest value x can be. So our domain includes all real numbers such that x is greater than or equal to 0, because we can't ever be smaller than 0. Now our range in this one is the same thing. If you look at our y values, our smallest y value is 0. After that we can only go up. So our range is all real values such that y is greater than or equal to 0. Okay, now we're going to use this graph of y equals the square root of x. It always has these square root functions always kind of have these shapes here. I kind of had a little bump in there where I shouldn't. And it has some transformations. Now, one transformation is when you add something to the entire function. In this example, we're adding 4. So adding 4 means you move the graph up 4. If I'd had minus 2, I would have moved the graph down 2. Now, inside the square root tells us that we are going to move right or left. If it's plus, we move to the left, and if it's minus, we move to the right. So this one is x plus 2, so we would take our original graph and move it to the left 2. If it was minus 2, I would have taken my original graph and moved it minus 2. So I have my original graph moved to the left 2 and up 4. So that's going to give me my starting point. But that's not quite the right answer yet because of this negative sign. So the negative sign means you flip it upside down. So rather than going up, you're going to go down. So now we know that our graph, when we get done, this was just to kind of get us a feel for it, we know that our graph is going to start at x equals negative 2 and y equals 4, so that's going to be our starting point. Negative 2, 4, and then it's going to go down. Okay, so we know it's going to start at negative 2 and 4. So I'll go ahead and put that one in here, negative 2, 4. Now the other points I want to put in are going to be related to these points. So from 0, I went up 1 to get 1. So from -2, I'll go up 1 to get -1. The reason I'm doing it this way is when I plug these values in here, I'm going to end up getting something that makes it easy for me to take a square root if I follow the same pattern. Now this only works because nothing is being multiplied by our x inside the square root. If it were, this wouldn't work. But this will work as long as nothing is multiplied by x. I want to follow the same pattern. So from 0 to 1, I went up 1. From -2 to -1, I go up 1. From 1 to 4, I go up 3. So now I'm going to go up 3 from here. Up 3 from -1, 0, 1, 2 gives me 2. From 4 to 9, I went up 5. So here I'm going to go up 5 to get that number. Okay, now I'm going to take this number and plug it in here to see what I get. Okay, so when I plug in -1, I get negative square root of -1 plus 2 plus 4. This gives me the negative square root of 1 plus 4, or -1 plus 4, which is 3. Okay, now when I plug in 2, I'll get negative square root of 2 plus 2 plus 4, which is negative square root of 4 plus 4, which is -2 plus 4, which is 2. Now when I plug in 7, I'll get negative square root of 7 plus 2 plus 4, which is negative square root of 9 plus 4, or -3 plus 4, or 1. Okay, so now I have my points. I have -2 and 4, -1 and 3, 2 and 2, and 7 and 1. Okay, so see how our graph looks like a square root function but flipped upside down, and it's moved over 2 to the left by 2 and up by 4. Now we need our domain and range. For a square root function, you're going to look at your starting point. Our starting point here is -2, 4. Notice our x's, this is going to the right, and our x's have to be greater than -2 because all the x values over here are greater than -2. So our domain is all reals such that x is greater than or equal to -2. Now if you look at our y's, the biggest y ever is 4. After that we're going down. Y is never bigger than 4, so our range is going to be all reals such that y is less than or equal to 4 because our y's have to be less than 4. Okay, let's look at another one now. This one's a cubed root function. So we're going to have a transformation of a cubed root function as well. So cubed roots are different from square roots. If you remember, square roots looked like, let me draw this up here somewhere, square roots looked like that. Cubed roots are going to look like that. And then we're going to have some transformation to move them up or down or right or left. So we're going to start by graphing just a regular cubed root function, regular cubed root. Now, unlike the square roots, which only went in one direction, cubed roots go in both directions. So my middle point is 0, 0. I put in x, well, let me write it here. This is just the cubed root, y equals the cubed root of x. Now I go off in either direction from 0. So the next point, -1 and 1. The cubed root of -1 is -1. The cubed root of 1 is 1. Now the next point I'm going to put in goes pretty far away from -1 because I want something that is a perfect cube so that I can take a cubed root of it. The cube of 1 is 1. If I go to the very next number 2, the cube of 2 is 8. So I have to go pretty far up to get the next one. So -8, and then the cubed root of -8 is -2, and then 8, and the cubed root of that is 2. So now I'll plot those points, -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And so our cubed root function looks like that. Now, just like square root functions, if I had something inside here, something x plus 3, for instance, I'd move it to the left 3. If I had x minus 2, I'd move it to the right 2. If I were adding something out here, I'd move it up. And if I were subtracting something out here, I'd move it down. If I had a negative sign, I'd flip it upside down. Multiplying by a number either stretches or shrinks it. Here I'm multiplying by 1/2, so that lets me know that my function is going to be vertically shrunk. It's going to be closer to the x-axis. So the points I'm going to put in here, 0, 0, that's going to be my middle point, and it's still my middle point because I'm not shifted left or right at all. And then also, since I'm not doing anything else on the inside here, I don't have to change these numbers. But just like I did with the square root, I could follow the pattern. So -1 is 1 less than 0, so I'd have that. -8 is 7 less than -1, so I'd have -8. So if I'd had -2 here, I'd put -9. If I had -3, I'd put -10. Okay, 1 and 8. Now here my numbers are going to be a little different, because if x is -8, then y equals 1/2 times the cubed root of -8. The cubed root of -8 is -2. So this is 1/2 times -2, which is -1. Okay, when I plug 1 in, y, or -1, y equals 1/2 times the cubed root of -1. That's 1/2 times the cubed root of -1 is -1. And this gives me -1/2. When I plug 1 in, y equals 1/2 times the cubed root of 1. The cubed root of 1 is 1, so this becomes 1/2. And when I plug 8 in, y equals 1/2 times the cubed root of 8. So that's 1/2. The cubed root of 8 is 2, so that becomes 1. So now I have my points. I have -8, -1. -1, -1/2, 0, 0, 1, 1/2, and 8, 1. Okay, so it looks a lot like this graph, only kind of squished in closer to the x-axis.